Hi, this is Miss Felice, and in this video I'm going to give you an introduction to the idea of ratios. So first of all, what is a ratio? A ratio is a comparison of two quantities using division. So a ratio compares two quantities using division, and there are three ways to write a ratio. Given that the letters A and B stand for quantities, represent quantities, we can write a ratio like this, A to B, which is one of the most common ways to see it. You can also write it like a fraction, because we know that all fractions are division problems, so A to B. And we can also write it A to B, written out with words. So those are the three ways that we can see a ratio written. But what is a ratio? Let's do an example. So down here, I have a picture of green squares and blue circles all jumbled together. I'm going to change my color here. So we want to write a ratio to represent each of the following. Based on this picture, number one, I want the ratio of squares to circles. Well, squares, I see 1, 2, 3, 4 squares. And there are 1, 2, 3, 4, 5, 6 circles. So the ratio of squares to circles is 4 to 6. Now the order that you write these does matter. It does matter. So if it's asking for squares to circles, you have to write it in that order. Now ratios are just like fractions in terms of simplifying. We have to simplify our ratios. So 4 to 6, we can divide both of these numbers by 2 and simplify this ratio 2 to 3. So that means that for every 4 squares that I see, there are 6 circles. But now that I simplified it and we have 2 to 3, that means for every 2 squares, there will be 3 circles. And I see that in my picture here. I can circle them. I can circle this section and see that when I have 2 squares, there are 3 circles. For every 2 squares, there are 3 circles. And so if I were going to fill that in, for every 2 squares, there are 3 circles. I could have also said for every 4 squares, there are 6 circles, but we like to use the simplified version. Now for number 2, we want the ratio of circles to squares. Very similar, but it's in the opposite order. So there are 6 circles for every 4 squares. And if we simplify that, our ratio would be 3 to 2, which means for every 3 circles, there are 2 squares. Very similar to what we had in the first one, but reverse order. Now, both of these ratios are considered part-to-part ratios. Part-to-part ratios because we were comparing the two different parts of this picture. We were comparing the circles to the squares, one part of the picture to the other part. So this is a part-to-part ratio. Now in number 3, we have a different type of ratio. We're going to be comparing the ratio of squares to the total number of shapes. Squares to the total number of shapes. Well, we know there are 4 squares. And how many total number of shapes are there? Well, there's 6 circles plus the 4 squares. That's 10 shapes in total. So the ratio of squares to total number of shapes is 4 to 10. For every 4 squares, there are 10 total shapes. We can simplify this ratio to 2 to 5, which means for every 2 squares, there are 5 total shapes. The fraction of shapes that are squares. Well, we know there are 4 squares out of 10 shapes in total. So the fraction of squares is 4/10. However, we know that we can simplify this to 2/5. So the fraction of shapes that are squares is 2/5. 2/5 of all of these shapes are squares. Number 4, the ratio of circles to the total number of shapes. So we know there are 6 circles and there are 10 shapes in total. So the ratio of circles to the total number of shapes is 6 to 10. And when we simplify that, our ratio is 3 to 5, which means that the fraction of shapes that are squares is 3/5. Originally, this fraction was 6/10 because 6 out of the 10 shapes are circles, but we simplified to 3/5. Now, number 3 and number 4, because we were comparing to the total of number of shapes, this is not a part-to-part ratio. This is called a part-to-whole ratio because we were comparing part of the picture to the entire thing, to the whole thing. So these were considered part-to-whole ratios. So a ratio is just a way for us to compare quantities. Let's do a couple practice problems, word problems, to help us with our ratios. So we're going to write ratios for each word problem, and then if we can, simplify. So number 1 says a pastry shop baked 24 cupcakes and 14 muffins. What is the ratio of muffins to cupcakes? Now it needs to be in that order. Muffins to cupcakes. It needs to go in this order. Muffins to cupcakes. Ooh. So first we write the number that represents muffins. In this case, it is 14. And then we write the number that represents cupcakes, which is 24. So our ratio is 14 to 24. However, we can simplify that. We can divide both of these numbers by 2 and get the ratio 7 to 12. So the ratio of muffins to cupcakes is 7 to 12. Now don't forget, I also could have written 7 to 12 like this, but this with the colon in between, this is your standard form. So I'm going to leave it like that. Number 2, in a fruit basket, there are 8 oranges and 6 apples. What is the ratio of apples to total number of fruit? And then after that, we'll ask what fraction of the fruit is apples. So the ratio of apples to the total number of fruit. This is going to be a part-to-whole ratio. Up top, in number 1, we did a part-to-part ratio because we compared the cupcakes to muffins. We didn't compare anything to the total amount of baked goods. Whenever we have the total, like in number 2, this is a part-to-whole ratio. Number 1 was a part-to-part ratio. So the apples to the total. Well, there are 6 apples. And then the total number of fruit, 8 oranges plus 6 apples, is a total of 14 pieces of fruit. So my ratio is 6 to 14. And of course, we can simplify 6 to 14. If we divide both of these numbers by 2, we get 3 to 7. So for every 3 apples, there are 7 total pieces of fruit. So what fraction of the fruit is apples? It's 3/7 are apples. Because for every 3 apples, there are 7 total pieces. And that's ratios. I hope this video helped, and if you have any questions, please let me know. Thank you.